So I said in my lesson video I was going to do a few more examples of applications with bearing. So this is just a continuation of my lesson video where I talked about method 1 and method 2 for bearing. So I'm going to show you now two examples and how to choose which method. So I've got two lighthouses are located on a north-south line. From Lighthouse A, the bearing of a ship 3,520 meters away is 139 degrees and 43 minutes. And then Lighthouse B has the bearing of a ship is 49 degrees and 43 minutes. So find the distance between the two lighthouses. Okay, so this one is really screaming for method 1 because we just have like these single directions, not in terms of other directions. And so I broke down how to approach method 1. So that's what we're going to use. So if you're not familiar with what I'm talking about, I recommend just checking out the lesson video, because there's kind of a lot of explanation that goes into it. So the big thing is that we just think of everything in a clockwise direction from due north. That's what we talked about in the other video. And that's kind of what makes lesson or method 1 what it is. And again, it doesn't have like a south or a north or these multiple direction things. So we just go straight to method 1. So we've got these two lighthouses located on the north-south line. So this is pretty important. Here is a north-south line, right? So you want to make sure that you're getting this picture right. And I think in the last example, I had them like on an east-west line. So you got to pay attention to this. Okay, and then it says from Lighthouse A, the bearing of the ship. So we know the distance is this. So here's the bearing. So from A, I need to go out this direction to the ship, okay? And this comes out to this 3,520 meters. So this is the first part. And then Lighthouse B says the bearing of a ship is 49 degrees and 43 minutes. So if I now draw from B, so going out this way, here's going to be me making that angle. And so it's going to be somewhere around here. Okay, so that is kind of the first part of this. And from here, now we need to label all of these angles in this triangle, okay? So this part here is pretty easy because it's just, we like couldn't just use that 49 degrees and 43 minutes. This angle here, we have to use what we know about non-acute angles. So this is 139 degrees and 43 minutes. So that would really technically fall into like a quadrant 2 type measure. So what I'm going to do is I'm going to take 180 minus this to get the equivalent non-acute angle. And I have a whole lesson where I talk about how to do that, but that's basically what you want to leverage here. So this comes out then to 40 degrees and 17 minutes, okay? So then, of course, now we've got to wonder, oh, what is this angle? And so to calculate that, I take 180 minus these other two measures that I've found. And I get, once again, it's 90, so we really like that. So I can just go ahead and label this 90, and it's like, woohoo. Okay, so now, since I know that this is a 90-degree triangle and I'm all nice and oriented, I can answer whatever questions I need. What was that question again? Find the distance between the two lighthouses. So I need this distance here. And I know one side of this triangle, and I know all my other angle measures. So when I think about this, I can just use my trig functions, and whatever trig function that relates this side, and this angle. So this would be the adjacent angle, and this would be the hypotenuse. So I can use cosine. Cosine of this is going to be the adjacent side over the hypotenuse. So there's everything that I need. And so now I can just go ahead and solve. So my x is going to be 3,520 times cosine of 40 degrees and 17 minutes. So that comes out to this whole number when you plug it in. And remember your significant digits. So this will be 2,685 meters. I can just round that up. And so there's kind of everything that goes into that. So feel free to like watch the explanation and kind of pause. You might find it very beneficial to write down these details and to work this out on your own versus just sitting and watching the video. These are kind of complicated. So you've really got to orient yourself, really get your hands dirty and draw everything. So now I want to compare the next problem. And I really think that these sound like totally different. So the next one, just notice like how my angles are given. South 52 degrees east. this is just screaming for method 2 as it is, okay? So the bearing from A to C is south 52 degrees east. The bearing from A to B is this. The bearing from B. So we have these three bearings. A plane is flying at 375 miles per hour. It takes 1.5 hours to go from A to C. Find the distance from B to C. So there's a lot of information in here, but like I said, we know we're going to use method 2. So we use north-south lines and then acute angles to show east or west direction. So again, I've broken this all down in my lesson video, and I'm just going to kind of jump into using this. So we're starting with the point A, and one thing I want to point out to you in how this problem is written. So I've got the bearing from A to C is south 52 degrees east, but look at the next part. The bearing from A to B is north 58 degrees east. So this is a little different from the problem that I did in the lesson video, because now I need to take both south and north into account. So when I start here with A, notice I've given myself some room on top and on bottom because I know I need to kind of take both these directions into account. So you start with that point, you've got your north-south line, and now I just want to make sure you really understand kind of how to interpret this. So this little measure here, this is really telling us to start south of A and then go 52 degrees east. The east direction is over here, okay? So I start south of A and go 52 degrees east. That's what I need to do. And so this creates this angle, and we go from this point A to C. And so I will just label that as 52 degrees just to make our lives easier. Okay, so let's move on to the next part. So I've got this, the bearing from A to B is north 84 degrees east. So again, this is really saying to go north of our point A and then 84 degrees east. So I start somewhere up here and then I go 84 degrees this way because this is the east direction. So going this way, I get some line that looks like this, and this should be, this should not be 840. This should just be 84. Let's see if I can erase this. 84 degrees. Just remember that's 84 degrees. Let's see, I'll fix it in the next one. Okay, so I've got this point B, and now notice that we're talking about the bearing from B to C is south 38 degrees west. So I need that north-south line going through B. Again, I just made like this little error when I wrote this out. You might see this printed wrong a couple of times, so sorry about that. Okay, so anyways, I've got my north-south line through this, and now I need to take this direction into account. This means that I need to start south of B and then go 38 degrees west. West is this direction, okay? So south 38 degrees west, I get this line here. And what I can say is that this little angle in here is 38 degrees. So now we're going to label everything that we can, and we also want to leverage what we know about transversal lines. Okay, so let's start with this little angle in here. How do I get this? Well, I know that this measure from here to here is 180. So to get to this, I can just take 180 minus the 84 minus the 52 degrees. And so I get this is 44 degrees. Okay, so this is 44 degrees. Cool. Now, using what I know about transversal lines, if this is 84, then this entire part here is also 84 degrees, okay? And I know from what I was drawing earlier that this little piece in here is 38, so I can easily figure out this last piece in here. I can just take 84 minus 38 to get 46. So now I've got this like triangle. I know this is 44, I know this is 46, so now I can figure out what is this last part. You probably have a guess as to what the last part is. So I've got 180 minus 44 minus 46. Bada bing, bada boom, it is 90 again. And so now our lives are much easier once again. And so now we're not quite done. We've at least labeled the angles. That's half the battle. But notice I have no, like a lot of times when you do these, you'll have a side labeled with like the length of it. We don't have that. So now I have to think about this. A plane is flying at 375 miles per hour and it takes 1.5 hours to get from A to B. So that's from here, A to B. So I have to figure out this length, okay? So if I take 375 miles an hour times 1.5 hours, what do I get? That'll give me 562.5 miles. Cool. Okay. So I've got this side labeled. And now what was it that I needed to do? I need to find the distance from B to C. So B to C is here. Okay. So now you just want to pay attention to like what have you actually labeled in this case. This side is the hypotenuse, right? Because this is 90, so the side opposite will be the hypotenuse. So this is the hypotenuse. I know this degree, and this is the side I want to get to, right? B to C. So once again, we're going to use cosine in this case. So I've got cosine of 46 degrees equals x over 562.5. Okay, and so then I can just go ahead and solve for that. So I would take 562.5 times cosine of 46 degrees, and I get this decimal, which you'd want to round again for your sig figs, which actually I think I should have labeled that round up 1. My bad. Okay, so there you go. So that is it for that one. So if you found this helpful, consider leaving this video a like or a comment or sharing or subscribing. And otherwise, if you have any questions, guys, you can always leave me one in the comments or contact me directly, and I'll talk to you next time.